Imagine standing at the edge of existence, gazing into a chasm so vast and so utterly empty that it defies reason itself. In the northern sky, nestled within the constellation Boötes, there lies a hole in the universe. A region not merely lacking stars, but devoid of entire galaxies. A cosmic wound stretching over 300 million light-years across, where matter seems to have never formed. This is not a simple void between galaxies. This is an absence so complete that it casts doubt upon the very structure of the cosmos. Astronomers call it the Boötes Void. Others simply call it the Great Nothing. Its existence is not just a scientific anomaly, it is a philosophical disturbance. To look into the Boötes Void is to feel the chilling breath of the universe's silence. It is a place where the known laws of nature seem to hesitate, a region so vast and barren that it feels more like an existential question than a location. What does it mean for the universe to contain such overwhelming emptiness? How can so much nothing exist in a cosmos built on matter and energy? In this documentary, we will journey into this darkness, not just to measure its scale, but to confront what it reveals about reality, time, and the mysterious forces that shape everything we are. The void beckons, and we are about to enter. In the year 1977, a young astronomer named Robert Kirshner aimed his telescope toward a relatively quiet patch of sky in the northern hemisphere. His gaze was fixed upon the constellation Boötes, a region not known for spectacular nebulae or blazing clusters. He was expecting to find what astronomers always find: faint glows, distant galaxies, the soft murmur of starlight whispering from the edges of time. Instead, he found something else entirely. He found nothing. Not dim galaxies, not the grainy background of cosmic dust. Just silence. Just black. At first, it seemed like a mistake. Perhaps a calibration error, a misalignment, maybe even a faulty detector. Kirshner and his colleagues checked their instruments again and again. Still, the void remained, a featureless stretch of sky where the expected sea of galaxies simply did not exist. In every direction of deep space, galaxies were expected to be evenly scattered, like glowing islands on a dark ocean. But this region of Boötes had none. It was not a gap between galaxies. It was an expanse devoid of them altogether. To understand why this discovery was so disturbing, one must understand how the universe is supposed to behave. Cosmologists had built their models on the principle of large-scale uniformity. That is, while the universe might be clumpy on small scales, it should look relatively smooth and consistent when viewed across hundreds of millions of light years. Galaxies should be distributed like streetlights across a vast plain, some closer, some farther, but always there. The Boötes Void did not fit this picture. It tore a hole in the very web of cosmic structure. The standard cosmological model, built upon the Big Bang, cosmic inflation, and the slow pull of gravity, predicts the formation of a filamentary universe. Dense regions form clusters of galaxies. Less dense areas become voids, but even those contain some material. Yet here was a region so utterly barren that it threatened to invalidate the model itself. If matter was evenly distributed after the Big Bang, then gravity should have eventually sculpted galaxies into every corner. But in the Boötes Void, gravity had seemingly abandoned its post. And then came the scale. As astronomers measured its boundaries, they realized this was not a small patch of cosmic silence. The Boötes Void stretches more than 300 million light-years across. To grasp that size is almost impossible. If the Milky Way galaxy were shrunk to the size of a coin, the void would be a sphere large enough to hold 1,000 such coins and still remain mostly empty. This was not just unusual, it was staggering. This was not a minor statistical fluke. It was a cosmic scream hidden in plain sight. The discovery sent shockwaves through the astronomical community. Conferences were suddenly filled with hushed discussions about the Great Nothing. Papers were rewritten, hypotheses revised. Some scientists suggested that the void was the result of an observational error or a coincidence. Others argued it must be the signature of some exotic physics we had not yet encountered. Whatever the explanation, the void demanded attention. The Boötes Void had gone from a blank spot in the sky to a mystery capable of rewriting cosmology. Kirshner named it the Boötes Void, after the constellation that had quietly hidden it for billions of years. But among astronomers, a darker name began to circulate: the Great Nothing. It captured more than just the emptiness. It hinted at the existential weight of the discovery. For in a universe expected to be full, a place so profoundly empty is not just a gap in matter, it is a gap in understanding. And sometimes, what we do not see is more terrifying than what we do. From this moment onward, cosmology would never be the same. The Boötes Void is not just large, it is beyond large. It is a structure so vast, so staggeringly empty, that it breaks the human ability to comprehend scale. It spans more than 300 million light-years from one side to the other. Light itself, traveling at over 670 million miles per hour, would take more than 300 million years just to cross its width. This is not a pocket of empty space. This is a chasm carved into the very structure of the universe. It is the largest known void in the observable cosmos. To picture its size, imagine shrinking the Milky Way galaxy, an object containing hundreds of billions of stars, down to the size of a coin. Now toss that coin into the Boötes Void. You would need to throw 1,000 more to even begin filling the volume. The space could hold 1,000 galaxies like ours and still remain mostly empty. It is like walking into Times Square expecting a crowd and finding only a single person standing alone. The silence becomes louder than sound. The emptiness feels unnatural. Now take this incomprehensible scale and anchor it to something more familiar. If the Boötes Void were superimposed on Earth, it would stretch far beyond any national border. It would be bigger than Manhattan, bigger than the entire state of New York. In fact, it would dwarf the entire continental United States many times over. This is a structure so vast that it could comfortably contain every human-made object ever launched into space, and still leave more than enough room for every planet in the solar system to orbit freely within it. But this is not just a question of size, it is a question of vacancy. The sheer lack of matter inside this volume is what truly stuns the imagination. Normally, even the emptiest regions of space are peppered with galaxies, filaments of dark matter, and faint glows of cosmic dust. But here, there is almost nothing. It is not merely underpopulated, it is hauntingly barren. A kind of cosmic silence, an architectural flaw in the structure of everything. It is a place where the laws of probability seem to have stopped applying. According to standard cosmology, regions this large should not be this empty. Matter should have spread more evenly after the Big Bang, forming a web of galaxies that stretches in all directions. In this view, large voids are expected, but even they should contain thousands of galaxies. Yet, in this immense hollow, astronomers expected to find at least 2,000 galaxies. Instead, they found fewer than 10. It is like discovering an entire ocean where physics had predicted a continent. The models failed. The universe whispered, "Look again." Standing before such emptiness, we cannot help but feel dwarfed, not just physically, but existentially. The Boötes Void is a reminder that we live in a cosmos of extremes, where size alone can be a source of wonder and dread. It makes us ask dangerous questions. What if this is not an anomaly? What if the universe hides other voids even larger and even emptier? What if the order we perceive is just a thin layer draped over deeper chaos? The Boötes Void is more than just a hole in space. It is a challenge to imagination itself. In a region of space where astronomers expected to find 2,000 galaxies, they found only 8. 8 lonely beacons suspended in an ocean of silence. These galaxies are not simply rare, they are survivors, the last inhabitants of a cosmic wasteland. They drift alone through the Boötes Void, like flickering lanterns in a vast and empty desert. Their isolation is not just physical, it is existential. They defy every expectation of how galaxies should behave, how they should form, and where they should belong. In the normal universe, galaxies live together. They are social structures. Most galaxies exist in clusters and superclusters, gravitationally bound to neighbors. They grow by interacting with one another, colliding, merging, and exchanging matter over billions of years. This interplay shapes their evolution. No galaxy is truly alone. They are citizens in a vast cosmic society, bound together by invisible filaments of dark matter and the pull of shared gravity. The Boötes Void galaxies, however, exist as cosmic hermits. The nearest neighbor to any of these void galaxies is often 50 million light-years away. For comparison, the Andromeda Galaxy, the closest large galaxy to the Milky Way, is a mere 2 million light-years from us. These 8 galaxies are 20 times more isolated than our own. It is the difference between living in a crowded city and being marooned on a remote island in the middle of an endless ocean. In every direction, there is only emptiness. No nearby galaxies to pull on them, no intergalactic currents to shape their fate. This cosmic solitude has profound consequences. Galaxies evolve differently when they are left alone. Without neighbors, the void galaxies have had no mergers to stir their stars, no interactions to ignite bursts of formation, no gravitational friction to sculpt their shapes. Many are smaller and dimmer than their counterparts in denser regions of space. They contain fewer heavy elements, a sign that they have undergone less stellar recycling. It is as if the void itself has stunted their growth, leaving them developmentally arrested. Scientists call this phenomenon galactic underdensity. It refers to a reduced rate of star formation, weaker gravitational bonds, and a slower evolutionary timeline. But this term cannot capture the eerie stillness of these galaxies. They are not just faint, they are quiet. Their stars burn with a calm that borders on lethargy. Their spiral arms, if they exist at all, are faded and subdued. There is no bustling factory of starbirth, no radiant glow of freshly minted suns. They are cosmic elders, slowly fading under the weight of time. That these galaxies formed at all within the void is remarkable. In the absence of the dark matter scaffolding that usually seeds galactic formation, their existence is an anomaly. It is possible that they formed billions of years ago when the void was still developing, before its repulsive gravitational field had fully emptied the region. And yet, against all odds, they persist, drifting alone, feeding only on the limited gas they carried with them. They are not thriving, but they are enduring, trapped within a forgotten corner of the cosmos. To study these galaxies is to peer into a parallel version of cosmic evolution, one where the usual rules have been bent or broken. They are witnesses to what the universe looks like in absence, in the near-total isolation of the Boötes Void. They teach us how galaxies change when stripped of context, community, and connection. Their existence deepens the mystery of the void. For they are not just residents of this emptiness, they are shaped by it, defined by it, and they may be the last remaining evidence that this region ever belonged to a universe filled with light. When astronomers first mapped the 8 survivor galaxies within the Boötes Void, they noticed something astonishing. These galaxies were not scattered randomly, as one might expect in a region defined by chaos and absence. Instead, they formed a line, an invisible thread stretching across the void from one end to the other. Like subway stations along a buried tunnel, each galaxy was spaced evenly, separated by roughly 40 million light-years, and glowing faintly in the dark. It was not a scatter of survivors. It was a structure. This improbable arrangement came to be known as a filament, a thin, thread-like structure of galaxies tracing an unseen framework. But this filament did not belong to the typical cosmic web. It lay inside the most barren region of known space, where structure was not supposed to exist. Its presence challenged everything astronomers thought they knew about voids. The void was not simply a hole in space. It was a canvas for something more ancient, more intentional, and far more mysterious. Imagine a colossal subway tunnel carved through the cosmic desert. Along its corridor, 8 glowing stations drift quietly, marking a path through the emptiness. The tunnel itself is invisible, constructed not of stone or metal, but of gravitational whispers and dark matter echoes. These galaxies are the lights that outline its edges, each one suspended in the dark, as if guided into place by a long-forgotten architect. It is a structure with purpose in a region defined by meaninglessness. This alignment is not likely to be random. In the observable universe, galaxies follow patterns. They cluster where matter is dense, and a void where it is not. In a void, especially one as extreme as Boötes, this kind of structure should not form naturally. Gravity alone cannot explain it. The symmetry, the spacing, the linearity, they all point to an underlying force or scaffold hidden from our sight. Something shaped this formation. Something left its fingerprints on the dark. One leading theory suggests that this filament is the ghost of an ancient structure, a remnant of a dark matter bridge that once connected galaxies across space. In the early universe, dark matter formed filaments that pulled normal matter along with them, birthing galaxies at the densest intersections. Perhaps this line of 8 galaxies is what remains of such a bridge, long since faded, but still barely alive. A fossil of gravitational architecture etched into the void's interior. What makes this theory compelling is the movement of the galaxies themselves. Observations reveal that these galaxies are not drifting aimlessly. They are moving in the same general direction, as though riding an invisible current. Their velocities are synchronized in a way that suggests a shared gravitational influence, even though no massive object can be seen. It is as if they remember a path laid down billions of years ago and are still following it, even as the rest of the universe pulls away. This filament may be the only roadmap through a region otherwise lost to time. Like a highway drawn through a wasteland, it connects nothing to nothing, yet still exists. It may be a relic from a younger universe, or a trace of dark energy's secret behavior. But whatever it is, its existence speaks to something profound, that even in the most silent corners of the cosmos, structure endures. The void is not just emptiness, it is mystery carved with symmetry, absence laced with geometry. A forgotten trail lit by 8 fading galaxies. The Boötes Void is not a static scar in the fabric of space. It is expanding, slowly, relentlessly, and disturbingly, faster than the rest of the universe itself. While cosmic expansion, driven by dark energy, stretches space in every direction, the void grows at an even greater rate. It is as though the emptiness is feeding upon its own absence, becoming more vacant with every passing eon. In the span of 1 billion years, the boundaries of the void have crept outward, pushing galaxies farther and farther from its center. This growth is not just another symptom of the universe's acceleration. Measurements reveal that the void is expanding at a rate approximately 10% faster than the Hubble flow, the average rate at which space stretches everywhere. That difference may sound small, but over cosmic distances and timescales, it is colossal. It means that the emptiness is not merely keeping pace with the universe, it is pulling ahead, hollowing out space faster than gravity or dark energy should allow. This phenomenon has a name: void instability. In cosmology, it describes how an underdense region, once formed, becomes increasingly empty over time. Gravity draws matter away from it, not into it. The result is a kind of runaway emptiness. Once a void begins to grow, it accelerates that growth naturally. Matter is not drawn in, it is expelled. Instead of behaving like a gravitational valley, the void becomes a hill, from which galaxies roll away like water flowing downhill. Emptiness breeds more emptiness. In this bizarre environment, gravity behaves in a way that feels inverted, not because the laws of physics have changed, but because the distribution of matter has shifted so extremely. In normal space, gravity pulls matter together, but near the Boötes Void, the lack of mass creates a gradient, an imbalance that sends galaxies cascading outward. This is not anti-gravity, it is gravity in retreat. The few galaxies near the edge of the void are not being pulled in. They are being subtly but inexorably pushed away. It is as though the void is generating a kind of vacuum pressure, not by sucking matter in, but by pushing it outward. Some cosmologists suggest that dark energy may be more concentrated within the void, or at least more active. That would explain the region's exaggerated expansion. In this view, the Boötes Void is not merely a hole, it is a pressure chamber, where dark energy exerts its influence with fewer obstacles, stretching space more freely, amplifying its own effects through the absence of mass. If this expansion continues, the Boötes Void will double in size within the next 5 billion years. That is roughly the timescale on which our own sun will exhaust its nuclear fuel. By then, the 8 lonely galaxies inside the void will be separated by such vast distances that they may no longer see one another. Each galaxy will become a solitary outpost, surrounded by blackness, disconnected from the rest of the cosmos, not by distance alone, but by the fabric of space itself, expanding too quickly to allow reunion. The accelerated growth of the Boötes Void is a window into the universe's far future. If dark energy continues to dominate, then all of space will eventually resemble the void. Galaxies will vanish beyond one another's horizons, stars will fade, matter will scatter, and the universe will stretch into cold, silent uniformity. In the Boötes Void, we see that future not in theory, but in practice. It is not just a structure, it is a prophecy, a glimpse of what happens when the universe begins to forget itself. At the very edges of the Boötes Void, something remarkable happens. As the emptiness grows outward, it begins to press against the matter-rich regions of the universe. And there, like water crashing into the banks of a river, galaxies pile up. These dense aggregations are known as void walls, immense structures of compressed galaxies that form natural boundaries around the void. They are not subtle, they are not gradual. The transition from nothing to something is abrupt, an astronomical cliff between emptiness and abundance. Galaxies along these walls behave strangely. They cluster more tightly than anywhere else in the sky, 3 times denser than the cosmic average. Some regions within the wall contain over 10,000 galaxies, all packed into an area that would normally host only a few thousand. It is as if the universe itself is recoiling from the void's interior, huddling along the boundary like villagers gathering at the edge of a burning forest. The galaxies do not fall in. They cling to the edge as though resisting a gravitational abyss. This sharp boundary is not what cosmologists expected. According to gravitational theory, matter should flow smoothly across the universe, from less dense regions to more dense ones. Transitions should be gradual. But the Boötes Void violates that principle. The edge of the void is not a slope. It is a wall, a dense, sudden structure that emerges like a tectonic fault in space. It is not a place galaxies pass through. It is a place they stop, as if something unseen and ancient holds them back. Observations of galaxy motion within these walls add to the mystery. Many of the galaxies are moving faster than expected, away from the void. Their peculiar velocities suggest an outward push, a repulsive force from the void's interior. This has led some physicists to propose that the void does not merely lack matter, it may actively repel it. The pressure gradient created by the expanding emptiness creates an environment where galaxies are not simply avoiding the void, they are being driven from it. Even light behaves differently near the void walls. As photons from distant galaxies pass through these dense boundary regions, they are deflected ever so slightly. The gravitational lensing effect, normally subtle, becomes measurable here. Light bends and stretches, creating warped images, cosmic funhouse mirrors, revealing invisible forces. These distortions show that the void walls are not just crowded, they are gravitationally potent. Their very presence warps the geometry of space itself. There are galaxies that stray too close to the edge, and some do not stop. They fall inward. But they do not fall like stones in water. They stretch, distort, and unravel. These galaxies display strange elongations and warped star formation patterns, as though the void is not pulling them in, but tearing them apart. Astronomers have identified galaxy groups near the boundary that appear to be dissolving as they approach the interior. It is not collapse, it is surrender, to silence, to isolation, to disassembly by emptiness itself. In many ways, the void wall is a battlefield, a confrontation between matter and the expanding void. Galaxies resist the tide of nothingness by clustering together, forming walls, filaments, and arcs of mass and energy. But they do not advance, they entrench. The wall is not a place of conquest, but of containment. Here, the universe pushes back against the hole in its design, trying to hold on to coherence as the void gnaws at its borders. The result is one of the most extreme density contrasts ever observed in space. The void walls are monuments to cosmic resistance. They are the last structures to form before structure itself ceases. Beyond them, there are no clusters, no galaxies, no gravity strong enough to coalesce matter. Just the infinite hush of the void. And so, these walls become more than physical formations. They are the boundaries of the known, the edge of presence, the edge of light. They represent the universe's last defense against a growing silence that, if left unchecked, may one day stretch from horizon to horizon. Where did the void come from? What force, what moment in cosmic history could create a structure so massive, so empty, and so defiant of everything we expect from the universe? The Boötes Void is not a hole left by chance. Its existence demands a deeper explanation, one rooted not just in astronomy, but in physics at the edge of human understanding. To explain the void is to ask how the universe builds, and fails to build, its grand architecture of matter, energy, and time. One theory points back to the earliest moments after the Big Bang, when the universe was still a hot, dense plasma. Tiny fluctuations in energy density, differences of only 1 part in 100,000, served as the seeds from which all future structure grew. Gravity pulled slightly denser regions into galaxies and clusters. Less dense areas became voids. But the Boötes Void is too large and too empty to be explained by normal fluctuations. It is like rolling 1,000,000 dice and seeing them all land on the same number. Another possibility involves dark matter, the invisible scaffolding of the universe. It is dark matter that provides the gravitational backbone upon which normal matter builds galaxies. But what if, in the region that became the Boötes Void, dark matter failed to condense? Perhaps something disrupted the initial clustering, leaving the region barren. Without the framework of dark matter, normal matter would drift aimlessly, never forming stars, never igniting light. The void may be a ghost town built on a missing foundation. Some physicists suggest that the void might be the remnant of a failed phase transition in the early universe. Just as water can freeze into ice or boil into vapor, space itself may have undergone phase changes as it cooled after the Big Bang. During such transitions, different regions might have settled into slightly different physical states. The Boötes Void could be a region where space got stuck in an alternate phase, a bubble with just enough difference to prevent matter from organizing into structure. Cosmic inflation, the period of rapid exponential expansion that occurred in the first fraction of a second, also leaves its fingerprints. During inflation, quantum fluctuations were stretched across vast distances. Most of these seeded the familiar web of galaxies. But some fluctuations may have created vast, underdense regions. The Boötes Void might be the fossilized imprint of one such fluctuation, an exaggerated dip in the energy field that inflation never fully smoothed out, a glitch that became a chasm. There is also the hypothesis that dark energy behaves differently in different regions of space. Normally, dark energy operates as a uniform force, causing the universe to expand more quickly over time. But what if it can concentrate under certain conditions? If dark energy became denser within the Boötes Void, it would accelerate expansion locally, pushing matter outward and preventing galaxies from forming. The void, in this view, is not just a passive absence, it is an active engine of repulsion. Other, more speculative theories propose that the void might contain exotic forms of matter, substances with negative energy density or repulsive gravitational effects. These would be invisible to our instruments, but capable of disrupting the formation of normal structure. Some even suggest that the void is a domain boundary, a region where the universe changes its rules, different physical constants, different interactions, a place where the laws of nature began to diverge, but never fully stabilized. In the Standard Model, the universe forms a vast cosmic web, with filaments of dark matter and galaxies weaving together like strands of silk. But the Boötes Void is not a hole between those strands. It is a rupture in the weave itself. Simulations struggle to create such voids, even when pushed to their extremes. That failure speaks volumes. The void may be the result of physics we have not yet written. It is not just an anomaly, it is a clue. A silent question embedded in space itself, waiting for the answer that may change everything we know. High above us, imprinted on the sky like a fingerprint from the dawn of time, lies the oldest light in the universe, the cosmic microwave background. It is the afterglow of the Big Bang, a faint radiation that has traveled for nearly 14 billion years. Across this canvas of ancient light, temperature differences appear as subtle ripples, evidence of the earliest seeds of cosmic structure. But in the direction of the Boötes Void, something unusual emerges, a patch colder than its surroundings, a void-shaped shadow cast across the universe's baby picture. This anomaly is known as the cold spot. It stretches across several degrees of the sky and is cooler by a mere few millionths of a degree. That may seem insignificant, but on cosmological scales, it is monumental. The cold spot is one of the largest coherent temperature anomalies in the cosmic microwave background, and its alignment with the Boötes Void is more than coincidence. It suggests that the void has been influencing light since the universe was less than 1% of its current age. As photons from the early universe pass through the void, they lose energy. This is a result of the integrated Sachs-Wolf effect, a phenomenon predicted by general relativity. In underdense regions like the Boötes Void, the gravitational potential changes as the universe expands. Photons enter the void, gain a slight energy boost as they fall into its shallow gravity well, but then lose more energy climbing out as the space itself stretches underneath them. What remains is a colder imprint, a cosmic receipt of this gravitational transaction. This cold shadow confirms that the void is ancient. It did not form recently. It has been a feature of the cosmos for nearly all of time. The cold spot acts as a fossil, a preserved scar from a period when the universe was still glowing. It suggests that whatever carved out the Boötes Void did so in the earliest stages of structure formation, and that process, whatever it was strong enough to leave a lasting fingerprint on the most fundamental radiation we can observe. Yet, even here, the mystery deepens. The observed coldness is smaller than models predict. If the void alone were responsible, the temperature drop should be greater. That gap between theory and observation hints that something else may be at work. Either our models are incomplete, or some unknown energy or structure is interfering. The cold spot remains one of the great unsolved riddles in cosmology. It is not merely a cooler patch of sky. It is a message from the beginning of time, whispered through emptiness. For decades, the Boötes Void was believed to be a singular anomaly, a colossal region of emptiness unlike anything else in the cosmos. But recent observations have begun to rewrite that idea. As telescopes have grown more powerful and sky surveys more precise, scientists have discovered something surprising. The Boötes Void may not be a single, unified structure. Instead, it could be the result of a vast merger, several smaller voids that drifted together across cosmic time to form one enormous hole in the universe. Picture soap bubbles floating on water. Over time, some drift together, touching and combining into a larger, oddly shaped form. This is how scientists now imagine the formation of the Boötes Void. Smaller underdense regions, each already deprived of galaxies, expanded and fused, their boundaries dissolving. The result is not a perfect sphere, but a sprawling patchwork of emptiness, stitched together by the universe's natural expansion. The Boötes Void may be a giant composite, a void of voids. Evidence for this theory comes from the galaxies that still remain inside the void. They are not evenly distributed, nor are they scattered randomly. Instead, they cluster into loose groups, like debris caught along the seams of a great fracture. These groupings hint at the original boundaries of the smaller voids before they merged. Spectroscopic studies show that galaxies in the northern section of the Boötes Void are older and more metal-poor than those in the south, suggesting different evolutionary histories, fragments of separate pasts. The subtle differences between these regions go beyond age and composition. They also extend to motion. Galaxies within different parts of the void are drifting at different speeds and in slightly different directions. These peculiar velocities reflect the gravitational tug-of-war that once shaped their surroundings. Even now, billions of years after the merger, the scars remain. The galaxies carry within them the imprint of ancient boundaries, like tectonic plates frozen mid-collision in the quiet depths of space. As these smaller voids merged, their gravitational properties compounded. The empty spaces amplified one another, producing a region with even lower matter density than any of its parts alone. This intensified the void's ability to repel galaxies, accelerating its expansion. That is why the Boötes Void grows faster than normal space. It is not just empty, it is synergistically empty, a runaway vacuum born from the union of lesser vacuums. The merger did not soften the void's nature, it sharpened it. If void mergers are common, the Boötes Void may be just a preview of things to come. As the universe continues to expand, more underdense regions may drift toward one another, fusing into supervoids that challenge our understanding of structure. The cosmic web may become increasingly torn, its filaments breaking apart as emptiness claims more territory. What we see in the Boötes Void is not only a relic of the past, it may be a template for the future, a blueprint of how the universe unravels over trillions of years. Most laboratories are full of things: particles, fields, machines, and matter. But the Boötes Void offers something else entirely: a laboratory made of nothing. It is a place almost free from interference, where matter is scarce, gravitational fields are weak, and the usual noise of the cosmos falls away. In this vast emptiness, the subtle forces that govern the universe become easier to detect. The void provides a unique and pristine stage upon which to observe how reality behaves when stripped down to its most fundamental elements. In normal space, the effects of dark energy are masked by matter, by stars, galaxies, and dark matter halos. But in the Boötes Void, those distractions are gone. The emptiness acts like a cosmic amplifier, allowing scientists to isolate dark energy's influence more clearly. Observations suggest that space within the void is expanding faster than average, possibly due to a higher concentration or greater efficiency of dark energy in this region. It is as if the vacuum has more room to stretch and no resistance holding it back. By tracking how galaxies near the edge of the void move and how light bends or redshifts as it travels through the region, astronomers can directly study the behavior of expanding space. These measurements help refine models of the universe's acceleration and provide clues about whether dark energy is truly constant, or if it varies across different environments. The Boötes Void offers a natural experiment in how space itself expands when relieved of matter's gravitational tug. It is the universe in a more exposed, raw state. The void also offers a unique vantage point for testing modified theories of gravity and alternative models of the cosmos. Some physicists believe that under extreme conditions, such as those in deep voids, the rules of gravity may deviate subtly from Einstein's predictions. Others propose that exotic particles or fields might operate differently in near-total emptiness. In this sense, the Boötes Void is not just a silent expanse. It is a kind of clean room where the faintest signals are not drowned out by the clutter of cosmic matter. Perhaps most haunting of all, is what the void reveals about the future. If dark energy continues to dominate the universe, then all of space may eventually resemble the Boötes Void, cold, stretched, and empty. Studying the void today is like peering into a time machine, catching a glimpse of what reality may become. It is not just a place to learn about physics. It is a place to understand our destiny. And in doing so, it becomes the ultimate laboratory, not of human design, but of the cosmos itself. We often think of galaxies as drifting aimlessly through the cosmos, pulled by gravity in all directions. But around vast voids like Boötes, a different picture emerges. Matter does not move randomly, it flows. The galaxies near the void are not still. They are caught in vast currents of motion, shaped by the gravitational imbalance between emptiness and structure. These flows, called galactic streams or cosmic rivers, trace the invisible web of gravity that stretches across the universe, guiding matter like water down a hillside. Galaxies along the edge of the Boötes Void are not falling into the emptiness. They are flowing away from it. The gravitational contrast between the underdense void and the denser surrounding structures creates a kind of pressure gradient. Galaxies move outward, toward the void walls, those great arcs of compressed matter. The flow is not chaotic. It is directional, almost rhythmic. Like a tide receding from a drained ocean basin, the void leaves behind a pattern in motion, as if space itself is being pulled taut. These galactic flows are not merely visual metaphors, they are measurable. Astronomers detect them through redshift surveys, gravitational lensing, and the peculiar velocities of galaxies. They form coherent patterns that map the underlying distribution of mass and gravity, even in regions we cannot see directly. In doing so, they turn the void into a kind of cosmic echo chamber, where the shape of the universe speaks through the movement of its contents. The flows give the void a voice, not in sound, but in motion. Unlike rivers on Earth, which cycle and return, galactic flows near the void are one-way journeys. Once galaxies begin to drift outward, they rarely return. The expanding void stretches the space behind them, making re-entry impossible. In this way, the Boötes Void becomes a kind of drain, not because it pulls matter in, but because it pushes it away, permanently. These galactic rivers tell a quiet story of separation, of matter fleeing from a growing silence. They are not chaos. They are the graceful retreat of the cosmos from its own vanishing core. When we look into the Boötes Void, we are not just peering into a remote region of space. We are looking forward in time. This enormous emptiness is not merely an exception, it may be a preview. As the universe continues to expand, matter becomes more isolated, gravity grows weaker, and vast regions of space empty out. The Boötes Void, cold and silent, mirrors what the cosmos itself may one day become. In this sense, the void is not an anomaly. It is a warning, a reflection of the ultimate direction in which the universe is drifting. Galaxies today are bound together in filaments and clusters, but even these structures are not eternal. The acceleration of the universe, driven by dark energy, will one day pull them apart. Over billions of years, gravitational bonds will be severed. Light will fade. The cosmic web will unravel. What remains will resemble the voids we see today, isolated, empty, and expanding. The Boötes Void, then, is not just a hole. It is the future, arrived early, a piece of the endgame suspended in the present. The most haunting aspect of the void is not its size, it is its silence. No new stars are born within it. Few galaxies remain to shine. Communication across its interior would take hundreds of millions of years. If intelligent life existed near its center, it would be profoundly alone. And that is what awaits the universe, not a cataclysm, but a fading. The lights will go out one by one, not in fire, but in isolation. The Boötes Void is the quiet rehearsal for the cosmic night to come. To study the void is to study the fate of everything. It shows us what happens when the engines of creation slow, when galaxies run out of fuel, when time stretches and light retreats. The void is not just space without matter, it is a reality without connection. And that is where we are all headed. Slowly, invisibly, inevitably. In this way, the Boötes Void becomes more than a scientific curiosity. It becomes a mirror, held up not to the past, but to the deep and distant future of the universe itself. To stare into the Boötes Void is to confront a silence deeper than language. It is not only a physical space, it is an existential one. Here, in this cathedral of emptiness, our deepest fears and most profound questions begin to surface. What does it mean to be human in a universe where entire regions are devoid of light, warmth, and matter? Are we a strange exception to a rule of silence? Or are we the temporary noise in a cosmos that will eventually fall quiet once more? In the face of such vast nothingness, one might feel small, insignificant. But perhaps the void gives meaning, not removes it. It is precisely because the universe is so indifferent, so hollow in places, that our thoughts, emotions, and connections stand out so vividly. Life is not a footnote in the cosmic ledger. It is a rebellion against it. We are awareness blooming in the dark, a moment of reflection in a universe that otherwise says nothing at all. The void is not our enemy. It is our contrast. We each carry our own voids, questions we cannot answer, silences we cannot fill. And perhaps that is why the cosmic void haunts us. It reflects something personal, something internal. Yet, in acknowledging it, we also transcend it. We build meaning not from what the universe gives, but from what we create in its absence. In that sense, the Boötes Void becomes not just a hole in space, but a canvas. And we, fragile and finite as we are, paint something luminous across its darkness. Long before galaxies were born, before atoms took shape, there was a storm of quantum fluctuations. Space itself trembled with uncertainty. Out of that churning chaos came the seeds of all cosmic structure and the scars of its absence. The Boötes Void may be more than just an empty region. It may be a preserved remnant, a fossil of the early universe's most delicate fingerprints, not carved by stars or matter, but by the push and pull of quantum fields as the universe inflated into existence. Some physicists suggest that immense voids may trace the boundaries of something even more exotic, a multiverse. During the period of cosmic inflation, space may have stretched unevenly, forming pockets of different physical laws. The Boötes Void, in this view, could be a boundary zone, where our universe brushed against another, leaving behind not matter, but absence. In that silence, we may be witnessing not just what is missing, but what almost was. A cosmic bruise from a collision we cannot remember. Even the quantum entanglement of the early universe may have left imprints in these vast structures. Voids could encode patterns of connection older than light itself, threads of correlation that span unimaginable distances. Though we cannot touch them, these patterns whisper of a time when all was one, when every particle danced with every other, and the difference between emptiness and presence had not yet emerged. The void becomes a memory, not of what has happened, but of what was possible. As we near the edge of understanding, the void offers a mirror, not of chaos or destruction, but of inevitability. If the universe continues to expand, then it will all eventually become like the Boötes Void, silent, stretched, cold, and vast. Galaxies will vanish beyond the horizon. Stars will die. Only emptiness will remain. And yet, in that vision, there is no tragedy. It is simply the nature of all things, to emerge, to flourish, and to fall back into quiet. We now live in a fleeting golden age. Galaxies are visible, stars are still burning, and life, at least here, has learned to wonder. This era, where darkness and light share the sky, will not last forever, and perhaps that is what gives it meaning. The Boötes Void teaches us that silence is the backdrop against which creation becomes possible. It is not a flaw, it is the canvas. The contrast that allows light, thought, and being to emerge and shine, even if only for a cosmic heartbeat. In the end, the void does not merely subtract, it reveals. It shows us the delicate balance that holds the cosmos together. It reminds us that emptiness is not the opposite of existence, but part of it. In the vast silence of the Boötes Void, we hear the faint echo of everything: the birth of space, the rhythm of expansion, the possibility of other realms, and the quiet miracle of our own awareness. In that which contains nothing, we may find the truth of everything. If you enjoyed this video, please give it a like and subscribe to our channel. Let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching, and we'll see you in the next one.